Good morning friends, welcome back to Pandika Tutorials. In this video, I want to discuss about highest response ratio next scheduling algorithm with an example. So I request everyone to watch the complete video for better understanding. In the last few videos, I have discussed about the first come first serve scheduling algorithm and shortest job first scheduling algorithm. In first come first serve scheduling algorithm, the criteria is arrival time. Among the process which are there in the ready state, which came early, means who has been admitted to the ready state early, they will be dispatched to the running state, because among n number of processes which are there in the ready state, only one process can be scheduled if you have one CPU. Is it clear? Or one if you have one processor. If it is a shortest job for scheduling algorithm, we will consider the burst time as the criteria. The process which has the less burst time as compared to the process which are there in the ready state will be dispatched to the running state. The issue with the first come first serve scheduling algorithm is the conway effect. The issue with the shortest job first scheduling algorithm is the starvation. What is this one? I will discuss with an example for you. Look at that, we have a ready state and running state. Okay, in ready state we will have the ready queue. In the ready queue, let's assume that process P1, process P2, process P3 are waiting because they came at 0 units of time. And they required burst time of 100, 20, some 10. Is it clear? Are you able to understand? Now, if you're using the shortest job first scheduling algorithm, the process which has less burst time will be dispatched to the running state. So if you look at process P3 has the less burst time, so it will be dispatched. So if you look at the Gantt chart, at 0 units of time, all the three processes has been arrived, but process P3 has been dispatched. Okay, let's assume that it is a non-preemptive scheduling algorithm. If it is a non-preemptive scheduling algorithm, if this process does not need any IO operation, then it will run for 10 units of time. Once it is completed, it will go to the terminated state. Okay, now look at here. At the 10 units of time, the process P4 and P5 has arrived. Exactly, let's take that. And they need some 19, some 18 units of burst time of the CPU. Then look at here, process P1 has arrived at 0 units of time. However, its burst time is 100, and this one also arrived at 0, but its burst time is 20. If you look at which process has the less burst time, process P5. So process P5 will be dispatched to the running state and it will execute for 18 units of time. So at 28 units of time, process P5 has been gone to the terminated state. By the time process P6 came at 15 units of time, it needs some 17 units of burst time. Then which one will be given priority? P6 will be dispatched to the running state and it will be running for 17 units of time. At 45 units of time, P6 will be completed. Okay, then let's assume that by this time no other process has came. Okay, so now P1, P2, P4 are there in the ready state. Now which has the less burst time? P4. So it will be dispatched and it will run for 19 units of time, which is nothing but 54, 64. At 64 unit of time, it will be completed. Then process P2 will be dispatched, because if you compare process P1 and P2, process P2 burst time is less. So P2 will run for another 20 units of time. At 84 units of time, it has been completed. Then process P1 will be dispatched and it will run for 100 units of time. So it will complete at 184 units of time. Look at the process P1 situation. It has arrived at 0 units of time, but it has completed its task, or it get the first response at 84 units of time. Its response is time is how much? How can you compute the response time? First time when it has entered to the running state minus its arrival time. 84 minus 0 is 84. At the 84th unit, it has entered and it has completed 184 units of time. So it, as this process has came first, but its burst time is very high, it was waited for a long time. So this is the issue with the shortest job first scheduling algorithm. To overcome this issue, the designers or the developers have developed a new scheduling algorithm called highest response ratio next scheduling algorithm. For any scheduling algorithm, we will have two parameters. One is the criteria and another one is mode. For the highest response ratio next scheduling algorithm, the criteria we need to consider is the response ratio. How can we compute the response ratio is W plus S by S. Now you can ask me, sir, what is W, what is S? I will discuss for you. W is waiting time. S is the burst time or service time. Okay. Now if you look at this formula, we can simplify it as W by S plus 1. Now what is the meaning of the criteria? If you have 3 process or 4 process which are there in the ready state, we will compute the response ratio of all the 4 process. Which process has the highest response ratio, that will be dispatched to the running state. Are you able to understand? Now, which process can be having the highest response ratio? Either the W should be very high, because W by S plus 1 is a constant. When this value will be very high, if your W is very high or your S is very small, then only this W by S will be very high, and if you are adding with 1, obviously it will be high. So what is meant by high W? If any process is waiting for a long time, or if any process need less burst time, then this value will be very high and response ratio will be very high. That process will be dispatched to the running state. So this highest response ratio next scheduling algorithm will favor the process which needs less burst time, and also favors the process which is waiting for long time. In the shortest Jaffa scheduling algorithm, it favors only the process which needs less burst time. But if the process is waiting for long time, it does not bother. It bothers only the burst time. To overcome that one, they have even considered the waiting time of a process. Okay. Is it clear? Now, mode. We have two types of modes. One is the preemptive and non-preemptive. The highest response ratio next algorithm uses the non-preemptive scheduling mechanism. Now, you can ask me, what is this TIEs or what is this FCFS? What is meant by TIE? Let's assume that two processes are in the ready state. We have computed the response ratio of P1 and response ratio of P2, and we got, let's assume that we got 5 and 5. These two processes got the same response ratio. Now which one I have to dispatch? There is a tie here. Then what we will do is that we will consider the first come first serve scheduling algorithm. First come first serve scheduling algorithm means it will consider the arrival time. Let's assume that process P1 came at 0 units of time. Process P2 came at 0 units of time. Where it came? It did not came to our house and your house. It came to the ready state. Now, which one will be dispatched? Process P1 has been dispatched, will be dispatched to the running state. Is it clear? Are you able to understand? Let's assume that you will be much tricky, sir. Let's take that both the process have been arrived to the ready state at 0 units of time. Now, response ratio, there is a tie. Arrival time is a tie. Then which process will be dispatched? Then we will look at the process ID P1 and P2. Which has the lowest ID? P1 has the lowest ID because this is 1, this is 2. 1 and 2, which is less? 1. So this process will be dispatched to the running state. Is it clear? So with this knowledge, let me solve this question. They have given 5 processes and they have given the arrival time and burst time. Now what they are asking us to compute the average turnaround time and average waiting time. To do that one, what we need to consider? We need to draw the Gantt chart. Okay. Always the Gantt chart will start from 0 units of time. Look at the process which have been arrived at 0 units of time. Yes, process P1 has been arrived. So process P1 is there in the ready state. There is no other process which are competing. If no other process is competing, why should we compute the response ratio? Because only this one is there. So we should not make the CPU idle. So what we will do, we will dispatch this process P1 to the running state as it is a non-preemptive, how much burst time or service time it requires, that much amount of time it will run, if we assume that none of the process requires the IO operations. Okay, then it will go to the terminated state. So process P1 will run for 6 units of time. Is it clear? It's well and good. By that time, look at what are the process have been arrived to the ready state. Process P4 has been arrived because it has came at 2 units of time. Process P2 has been arrived. These two processes have arrived. Now, which one we have to give the priority? We need to compute the response ratio of both the process. So, response ratio of process P2, I will represent it as RR2. Okay. How we can compute W plus S by S? Okay, where W is the waiting time. Now look at here. P2 when it has arrived at 5 units of time. P4 has arrived at 2 units of time. What is the current time? 6 units. It has arrived at 5 units of time. So it is waiting for 1 unit of time. So waiting time is 1, and S is the service time or the burst time. What is the process P2 burst time? It is 10. So 1 plus 10 by 10, which is equal to 11 by 10, which is equal to 1.1. Similarly, we will compute the response ratio of process P4, which is nothing but RR4. Okay. Now, it came at 2 units of time. Currently, the time is 6 units of time. So, it is waiting for 4 units of time. And look at the burst time. Burst time is also 4 units. So, 4 plus 4 by 4, which is equal to 8 by 4, which is equal to 2. Now look at 2 is greater or 1.1 is greater. 2 is greater as compared to 1.1. So process P4 has the highest response ratio as compared to the process P2. Then process P4 will be dispatched to the running state. And how many units of time it will run? It will run for 4 units of time. So at 10 units of time, it will complete its task and will go to the terminated state. Okay. Right now, process P2 is only there in the ready state. But once the 10 units of time is completed, look at what are the process has been arrived. Let me keep the tick mark what are the process have been completed. P1 and P4 has completed. Now P2 is in the ready state. P5 has been arrived at 5 units of time. Is it clear? Are you able to understand it or not? Now, process P3, it will arrive at 12 units of time. Even till 10 units of time is only completed, it has not arrived. Now, when it has arrived, P2 at 5 units of time, P5 at 9 units of time. Now, again, there is a competition. We need to compute the response ratio. Let me compute the response ratio of process P2, which is W plus S by S. W plus S by S, where W is the waiting time. Process P2 has arrived at 5 units of time. Right now, 10 units of time is done. So, it is waiting for 5 units of time. Is it clear? And service time or the burst time, which needs 10 units. So, 15 by 10, which is nothing but 1.5. Similarly, you compute the response ratio of process P5, which is 9, arrived at 9 units of time, but it's currently 10 units. So it is waiting for 1 unit of time. And look at the burst time, which is 2. So 1 plus 2 by 2, which is nothing but 3 by 2, which is equal to 1.5. This situation came, the tie has happened. Okay, both the process P2 and P5 got the response ratio as 1.5, which is equal. So there is a tie. If there is a tie, we will look at the first come first serve scheduling algorithm. Meaning is that which process has been arrived first, which process is waiting for a long time. Process P2 has arrived at 5 units of time. Process P5 has arrived at 9 units of time. Among them, which has arrived first? P2 has arrived first. So I will dispatch the P2. Okay, and it needs 10 units of time. So I will run for 10 units. At 20 units of time, it will complete its task. By the time process P3 has arrived. So already P5 is there. P3 has arrived. P2 is completed. Okay, now When P5 is arrived at 9 units, process P3 has arrived at 12 units. Again, we need to compute the response ratio of both the process. Let me compute the response ratio of process P5, which is W plus S by S. Okay. Now, currently 20 units, it has arrived at 9 units. So, it is waiting for 11 units of time. So, 11 plus, what is the process P5 burst time? 2 units. So, 11 plus 2 by 2, which is nothing but 13 by 2, which is 6.5. Am I right? Similarly, response ratio of process P3 is equal to, it is waiting for 8 units of time. Currently, it is 20 units of time. It has arrived at 12 units of time. So, it is waiting for 8 units of time. And process P3, burst time is 8 units. So, 8 plus 8 by 8, which is equal to 16 by 8, which is equal to 2. So, which process has the highest response ratio time? Sorry, highest response ratio? The process P5 has the highest response ratio. So, it will be dispatched. Okay. Now, how many units of time it needs? Only 2 units. So, at 22 units of time, it has completed. Now, no other process has arrived. Only P3 is there. So, it will be dispatched. Okay. And how many units of time it needs? 8 units. So, at 30 units of time, all the process have been completed their tasks. Okay. Is it clear? Now, we need to calculate the completion time of each process. Are you able to understand? So, process P1, when it has completed its task at 6 units of time, process P2, 20 units of time, process P3, 30, process P4, 10, process P5, 22. Once we got the completion time, we can easily compute the turnaround time, because turnaround time is equal to completion time minus arrival time. Okay. What is the completion time of this one? 6. Arrival time is 0. 6 minus 0 is 6. 20 minus 5 is 15. 30 minus 12 is 18. 10 minus 2 is 8. I hope it is visible as 15 and 18 and 8. 22 minus 9 is 13. Now we have to compute the waiting time, because usually they will ask the average waiting time and average turnaround time. Waiting time can be computed as turnaround time minus burst time. So 6 minus 6 is 0. 15 minus 10 is 5. 18 minus 8 is 10. 8 minus 4 is 4. 13 minus 2 is 11. Similarly, if you want to compute the response ratio, you will get the same as waiting time. If you want to verify, you can verify. How I am saying that the response time and waiting time will be same, because it is a non-preemptive scheduling algorithm. But let me discuss how can we compute the response time is. First time when it has entered into the running state minus arrival time. Look at the process P1. It has entered the running state at 0 units of time. Arrival time is also 0. 0 minus 0 is 0. Similarly, P4, it has 6 minus 2, which is 4, correct. P2, 10. 10 minus 5 is 5, correct. P5, 20. 20 minus 9, 11, correct. P3, 22. 22 minus 12, 10, correct. So, all the process response time we got, which is equal to waiting time, because it is a non-preemptive scheduling algorithm. Is it clear? If it is a preemptive scheduling algorithm, it will be different. Now, once we got the turnaround time of all the process, we can easily compute the average turnaround time. So, average turnaround time is equal to turnaround time of all the process, which is 6 plus 15 plus 18 plus 8 plus 13 by number of process, which is 5. Similarly, average waiting time is equal to sum of all the process waiting time by the number of process, which is 5 plus 10 plus 4 plus 11 by 5. See, there is a 0, so I did not add it. 0 for anything. 0 plus anything will be that anything only. Okay. So this is the average turnaround time and average waiting time for the given question with respect to the highest response ratio scheduling algorithm. I hope it is clear for you. If you have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.